I'm at the European Climate Change Adaptation Conference in Rimini, and I'm joined by Susanne Mecklenburg from the European Space Agency. Susanne, thank you for joining me.
Pleasure.
Okay, so Susanne, I don't know if this is a sort of a dumb question, but when I arrived at the Congress yesterday and I saw the European Space Agency, I wasn't sure what the role is of the ESA in climate change. Can you tell me how you're involved, how you're contributing?
The European Space Agency is very involved in supplying actionable climate information on the basis of the space data that we are actually producing. So in ESA, we have the Earth observation program, so basically looking back with our satellites towards Earth. And because we are doing this, we can actually measure what the state of our climate is and how climate is actually changing over the last couple of decades. We do that with a large fleet of satellites that is now available, also in collaboration with the European Union and with EUMETSAT in Copernicus, for example. And what we measure is something called the essential climate variables. So we measure the physical entity that we measure with a particular sensor, but then, a body called the Global Climate Observing System has developed a set of climate indicators called essential climate variables. And they tell us what the state of the climate is and how it is actually developing. So, for example, sea surface temperatures we can measure. We can measure land surface temperatures. We can measure what sea level change we actually experience. And these are data that are important to know in the whole context of discussing global climate policies. So we're doing the entire food chain from developing the satellites up to operating these space missions, supplying the data, but then also using them to supply information for climate change.
Because the data that you're supplying is key for, say, local authorities, local communities, businesses to actually achieve Paris Agreement goals, right?
Yes, I would probably make a little bit of a difference between mitigation and adaptation. Mitigation is something where we are looking probably more at global data to understand what the state of the climate is and what the global warming at the moment actually comes to. Adaptation is more of a local and regional issue, if you really think about it. And I think sometimes, even though space data are, I call them beautiful and skillful, because they are global, they're timely, you can have different measurements over the same point on the Earth from different sensors, so you can actually understand a system and how a system evolves. But sometimes they don't have the right maybe spatial or temporal resolution for a particular phenomena that we would like to look at. For example, an extreme event. So are we at the right time, at the right place to actually really capture it? But we can actually look at both of those aspects. And also maybe not coming back to the mitigation part, one of the things that we're doing at the moment is that we are developing methodology and R&D to help with the reporting requirements that states that have signed up to the United Nations Framework Convention for Climate Change, the Paris Agreement, have to fulfill every 5 years in the global stocktake. And we're trying to compare our approach, which basically looks from space and inverse modeling, so you need to know where, for example, the emissions are coming from, to the approach that states do individually, by which they, for example, know what type of industries they have, population, land cover. And then they apply a sort of statistical model and a bottom-up approach. But, both of these things are, let's say the bottom-up approach is, of course, a little bit subjective to the information that you might have available on a national level. So we wanted to introduce a more objective measurements that is more of a global scale. So this is the type of thing we try to help with in the context of global climate policies.
Okay, and how do you ensure that the data or the data products, the climate services you're providing are really useful to a broad range of stakeholders and applicable?
Yeah, I think one really important point in the discussion of space data in the sort of climate discussion is that they are precise, that they're well validated, that they're trustworthy. And that's very much the job of a space agency, to make sure that the data that we are supplying are of very high quality and that we can really trust them. And then I would say that the European Space Agency's role is really more on the research and development and pre-operational development. We sort of initiate these activities and then we give them on to, let's say, operational climate services, like, for example, the Copernicus services from the EU. And we have transferred a lot between, the sort of more R&D focused outlet to, for example, the Copernicus Climate Change Service. And that's important to have this link to actually really transfer a trustworthy data set and approach to then make it into an operational environment where people who are not necessarily remote sensing specialists understand what type of data they're actually using and what they're using them for.
Yeah, because otherwise it's, it sort of gets into the data set and stops there, right?
Exactly.
Yeah. So there's other things that you're doing. You've obviously got like advanced technologies like AI. I know there's the Destination Earth digital twin platform that you're involved in. Can you tell me a bit about how that helps with climate modeling?
Digital twins are really important in a sense that we understand what a system is. So we can actually combine a lot of different data sets to see how particular environments actually develop. They are a sort of modeling, forecasting tool for us to understand maybe even in a number of decades where we will be. And this is actually important for adaptation because we are building resilience to a changing climate. So we can actually then prepare in a good way when we are coming to this point. And this is something that we can do with digital twins. You can have a digital twin of the Earth, but we are, for example, at the moment developing digital twins for extreme events. We have a digital twin for the Mediterranean area, for example, to see how warming is actually impacting this particular area, and so on. So basically, that's really important. AI, of course, AI and machine learning is something that we are looking into very deeply because many of these techniques can actually help us to construct climate data records that are actually going into these digital twins, which is a very fast method or technique to create climate data.
Yeah, because without these, we're essentially trying to analyze a rapidly changing situation, right? I mean, each day climate change is accelerating. Each day is different from the last, right? What have been the major change? I don't know how long you've been working on this with the ESA. What have been the changes that you've observed over time in terms of the climate?
Well, I mean, the last 2-3 years have been quite important in global climate policy, but also in what we actually see in terms of status of the climate. 2024 was the first year where we went over the crucial threshold of 1.5 degrees centigrade. So this was a major negative milestone, I would say, in looking at climate is actually developing at the moment. So we have seen that I think the awareness of that we need to do more to reach our collective responsibility to counter global warming has really sunk into people's perception and conscience. Really, you can really see that. Meanwhile, also what I think has a little bit changed is that we have shifted from talking mainly on mitigation more into the adaptation part, and this is something that we see here at this particular conference. And at the same time, I want to say, let's not forget about mitigation. Adapting is good, but I think we really need to reverse where we are going with our mitigation goals. There's something called the nationally determined contributions. So each country would basically say by which time they are net zero, for example. And then they put measurements in place in terms of their industries, how they produce their energy, for example, how they use their land. And we do need to strive towards fulfilling these nationally determined contributions, because what we've seen in the last assessment in 2023 is that we're actually net increasing almost our global warming with the promises that we have done at the moment. So this is always very important to also remember that we are actually at the moment collectively failing our promises.
I'd love to end on a more positive note than that.
Of course.
Well, that's obviously very concerning. Although I know good things are happening as well. I wonder if you could share any sort of positive experiences where, your data has really helped people.
Yes. Last week I was at the United Nations conference for the oceans in Nizza. it's a COP meeting, so quite high level in terms of policy and policy makers. And I think what I've seen there is really a much higher awareness of what is happening at the moment, and really putting national policies and plans in place to reverse this effect. And I think this awareness is really positive to see. It's also very positive to see here so many regional and local policymakers, council members, let's say, for example, for Rimini, I think we heard from them in the opening session,
Right.
where they really think about how to make their environment in which they live more sustainable, also using space data. And this
Yeah.
is really great. We have taken this on board also in the European Space Agency by designing the next generation of satellites, where we really concentrate on applications that go more in the direction of sustainability and adaptation, where we have smaller temporal and spatial resolutions, so that we can actually really help hands-on with actionable climate information
Right.
that are really tangible for somebody who is out there implementing policies to counter the effect of climate change. So I think it's not all hope is lost, I would say. Not at all, but I think we need to pursue that even more.
Yeah.
I think we need to maintain this collective conscience in the future.
Well, yeah, hopefully events like this will help. I think it's very true what you say. I mean, they say knowledge is power. If that's so, then data is really a superpower, isn't it? So that makes you a superhero.
Well, let's see about that.
Susan, thank you very much for joining us and for sharing your vast wealth of insights. Thank you.
Very good. Thank you very much.